Okay.
All right, so this recording is for anybody who is gone today for Alg II.
We need to see her again. It's not like she's dying.
So I started these notes already, and we said that rate of change was equal to slope. That's what slope is, rate of change. Slope is equal to the change in y over the change in x, which is the rise, over the run, which is the second y coordinate. Subtract the first y coordinate over the second x coordinate minus the first x coordinate, okay? My algebra kids who come up do some bad things, okay? One bad thing that I see done a lot is they want to put the x on the top and the y on the bottom. Why would they want to do that? X comes first. Okay, hold on. What? Yes. Sure. Okay. That sounds good. You are supposed to be leaving here in about 10 minutes. Okay. In about 10 minutes you're supposed to leave, so April said to like kind of pack up your stuff-ish and head on down or whatever here shortly. Whatever, make sure you write this assignment down. You can watch this video if you want to watch the video.
You going to Florida?
Alright, so y2 minus y1 over x2 minus x1. They want to put the x's on top because the x's come first, right?
Yeah.
No, you're going to put the x's on the bottom, okay? So rise over run. Rise is up and down. Which coordinate goes up and down on an axis? Y. That's why it's the y's first, right? The run is the x's. Runs go left and right. That's the x's, okay? So the constant rate of change, the table shows the temperature of a solution after it has been removed from a heat source. So let's talk about what's going on here. This is a beaker, like what's in Mr. Moo's class, and then you put it under, what's that little heat source? Remember what that's called? A Bunsen burner, right? You put a Bunsen burner and you put a little beaker on top of it, okay? So we have taken that beaker away from the heat, right? We've taken it off of the Bunsen burner and it's just sitting now, right? It was, at a time of 0, it was up to 143.6 degrees. That was how high it was. And then after 2 minutes, it was at 139.4. And after 5 minutes, it's 133.1. 8 minutes is 126.8. And it keeps going down and down and down, okay? All right, we need to figure out how much it's going down. Find the rate of change in temperature for the solution. Okay? We need to find how much it's going down. How do we do that? Anybody have any thoughts? Rise over run. So basically, how much is it rising versus how much is it running? Let's look at the rise over run. Okay, we'll do that one way. So, how much basically is it rising from 143.6 to 139.4?
Negative something.
It's going to be negative. It's going down, right? So subtract those two numbers. You can use a calculator. I don't care. Let's figure out how much it's going down.
Did you say 143.6? There's a decimal?
Yes, there is a decimal there. Yep. It's a little tiny one. There's decimals right here. He's really tiny. You can't see him, sorry. There's a decimal in between each one of those. So how much is it going down the first time? From 143.6 to 139.4. 4.2. It's going down 4.2. Okay? Now, from 139.4 to 133.1. How much is it going down? It's going down 6.3. Okay, now from the next one, 133.1 to 126.8. What? Somebody do the last one.
It's, whoa, just kidding.
Wow, just kidding. Negative 6.3. Right?
Yeah.
Yes, yes. Now, do the last one. 126.8 and 118.4. What's that? 8.4. Is it going down the same amount every time?
No.
What?
No.
We have some no's. We have one yes. Somebody said yes.
He's being...
Well,
No.
he's the only one that's right.
What?
Oh, because the times are
Oh.
Look at the times. So this is 0 to 2 minutes, right? This is 2. Oh my God, you were guessing, you little stinker. Okay, so 2 minutes have elapsed from 0 to 2. How about from 2 to 5?
3.
is 3. How about from 5 to 8?
3.
3 and 8 to 12?
4.
4. So if we're doing the rise over the run, right? The rise is negative 4.2 the first time. Over the run is 2. Okay, what is that? Negative 2.1 if you divide. Ooh, wait, there we go. Negative 2.1. Okay, now let's do the same thing. We have negative 6.3 and we divide by 3. That is negative 2.1. Okay, and we have negative 6.3 again, and we divide that by 3 again because that's my next interval, and that's negative 2.1. And what's the last one? Negative 8.4 divided by 4, which is negative 2.1. So what does negative 2.1 stand for other than my slope? That's the rate of change. Okay, so speak about that in context of the problem.
That's
Negative
how much
2.1.
the temperature goes down
Every minute. So it is decreasing 2.1 degrees per minute. That's what my rate of change is. Yeah? Okay? Now, if we wanted to do the whole y2 minus y1 over x2 minus x1, we can do it that way as well. Let's look at these two guys right here. This guy and this guy. Okay, those two coordinate points, I'm going to do this in yellow all the way at the right, or at the left. Okay, so our two coordinates are 0, 143.6, that's one coordinate, and the other one is 2, 139.4. Okay, we're going to do y2 minus y1 over x2 minus x1. We're going to see if we get negative 2.1. Okay, all right, so what's the y2 part?
The second y.
The second y, what? 139? 139.4 minus the first y. That's the first x. This is like x and y, right? This is the first x and the first y, and this is the second x and the second y. Does that make sense? X, y, okay? So this is your second y, and this is your first y, yeah? Does that make sense to you? Okay, so we subtract 139.4 minus 143.6 and divide by, what's the second x coordinate? 2, and we subtract 0. 2 minus 0. Okay, so do you see your y2, y1, blah, 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 all that stuff? Okay? All right, so if I subtract 139.4 minus 143.6, that is negative 4.2 all over 2 minus 0, which is 2, and we said that that was negative 2.1. So we did, looking at the table, just doing rise over run, or we can do y2 minus y1 over x2 minus x1, right? And get the same answer. You don't have to do both, obviously, because we got the same answer. But I'm just showing you, logically, you can look at this table and say, hey, we're going down 4.2 in 2 minutes. That's going down 2.1 in 1 minute, right? Or you can do y2 minus y1 over x2 minus x1. Does that make sense? You have options now. Options are good, okay? Example 2, average rate of change. Refer to the graph at the right. Find the average rate of change for the sales of both digital music and ebooks from 2004 to 2009, okay? So 2004, 2009. Let's do music over here, and let's do ebook over here. Okay, music here, ebook here. So in 2004, I'm going to do 2004, comma something, 2009, comma something. I'm not going to write over here. And then ebooks is 2004, comma something, 2009, comma something. Okay, and we look at the graph to figure out what that something is, right? It makes it really nice for me just to be able to find my points first. Okay? So 2004, which one is ebook, by the way? The bottom one is ebook, okay? So where is it at in 2004? 9.6. So in 2004, we're going to put 9.6. Okay? In 2009, what is it at? That's this guy right over here. 2009. 165.8. This is in probably millions, by the way. Millions, I'm guessing. Millions of dollars, yep. Okay, ebook. What's ebook in 2004? 200 million. Okay, we're just going to put 200. All right, and then digital music for 2009. 3,100. So that is, what's 3,100 million?
We did that.
What?
The ebook numbers should be on music and music should be on ebook.
Oh, poop. Okay, blah, blah, blah. Ebook, sorry, ebook. And this guy is music. I've labeled them wrong. You're right. I was just seeing if you were paying attention. And you got, yeah, right. So, we have this switch around. Okay, now what? What is 3,100 million, by the way? Well, like in more educated terms. 3,100 million. 3 billion. 3,100 million, right? That's another way of saying that. Okay, so now let's do our y2 minus y1 over x2 minus x1, and I'm going to run maybe out of room here. Okay, what is your second y coordinate over here for ebook? Yes, so it goes x and then y. X is y, so here's my second x, or second y. 165.8 minus 9.6. And then on the bottom I have 2009 minus 2004. That's going to be my slope, my rate of change. Yeah? So on the top, 165.8 minus 9.6. I can maybe do that in my head. 156.2. Yes, 156.2. And then 2009 minus 2004 is 5 years. So what is that per year if I divide that out? 156.2 divided by 5. 31.04. 31.24, you're right. 31.24. Okay, so that is the amount of dollars that guy increases per year for ebooks. Okay, now music then is going to be bigger or smaller than that? Is music increasing at a faster rate than ebooks? Yes, so that number should be bigger. So we're going to subtract. What's my first number? Subtracting. 3,100 minus 200 over 2009 minus 2004. If you want to take some shortcuts on the bottom, 2009 minus 2004, you might be able to do in your head and just put 5 down there, right, rather than writing the whole thing out. You can take some shortcuts. I don't care. That's fine. 3,100 minus 200. 2,900 divided by 5, and that is 580. 580. $580 million is how much that's increasing per year, because music is going up and up and up and up and up, right? Faster than people like to read. People like to listen to music more than they like to read, unfortunately, right? That's why people are stupid in this world, because their reading comprehension is like low. Whatever. I don't.
You do?
See, there's my rate of change. Compare these rates. So what can we say for a comparison? I've already kind of said it.
Ebooks are more popular, not ebooks. Music
Go
is
on.
more popular.
Music is increasing at a faster pace. Music is increasing at a faster pace, right? That's what slope does. It's talking about the rate at which it is changing. It is changing faster. Make sense? Good? Beautiful. All right, so now, I cheated. I gave you the formula ahead of time. Now they're introducing you to y2 minus y1 over x2 minus x1. That's exciting. We already knew that, right? So here's the formula if you want it written down. It is the change in the y coordinates and the change in the x coordinates. It's how much y is changing over time, how much x is changing over time. Okay, so let's go down to example 3. We're going to apply this. Example 3, find the slope of the line that passes through the point -3, 4, 3, and 2, 5. What in the heck does that mean? What does that mean? That's exactly right. y2 minus y1, x2 minus x1. So this is my x, this is my y, this is my x, this is my y. Right? Okay? So x1, x2, y1, y2. Okay? Do that real quick. I'll give you a head start. Go. Don't think you did it right.
Really? Fine, I don't know. This is beyond, dummy.
I'll tell you right here in a second. Okay, did you get an answer? Y2 minus y1, x2 minus x1. Okay, I'm going to do something different. I'm going to do this. I'm going to see. You guys know the answer to this problem, or I hope you did it right at least, okay? We're going to do the same points. We're going to do the exact same points, but instead I'm going to call this x2 and y2, and I'm going to call this x1, y1, right? Okay? Usually you do the first one as your ones and the second one as your twos, right? But I'm going to flip them around. I'm going to see what happens to this, okay? What do you think is going to happen?
Get the same thing.
You think you're going to get the same thing, or it's going to be the negative?
No.
You think it's going to be different if I screw it
Yeah,
around?
it's gonna be a
No, it'll be the same. They'll both
It's
be.
still
No.
working.
Okay, so let's see. Let's see
yeah.
what happens. Let's see what happens, okay? So, if I do it in this order, my second y coordinate is 3, and my first y coordinate is 5, so 3 minus 5, right? Okay, the bottom, I would do negative 4 minus 2, yeah? x2 minus x1, okay? So, 3 minus 5 is negative 2. On the bottom, negative 4 minus 2 is negative 6. Those two guys should cancel out. Those two negatives should cancel out, right? To become positive, 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 and 2 and 6 becomes 1/3. Is it the same or is it different?
The same.
It should be the same. It should be the same. All right. Now I'm gonna do it. The correct way. Okay. Both of them are correct since you get the same answer. But I'm gonna do it this way. Okay. So here, my y2 is 5. My x2 is 3. 5 minus 3 over 2 minus a negative 4. What happens when you minus a negative 4? Negative, negative becomes plus. That's what you did wrong. Okay. 5 minus 3 is 2. 2 plus 4 is 6. Okay, so look at the differences here. Look at the differences here. Stop. When we did it the backwards version, we had negative 2 over negative 6, right? But that's the same thing as positive 2 over positive 6, right? So you just ended up with a double negative over there, but it's going to end up being the same thing no matter what. So if you are stuck on a problem and you're like, oh crap, which one is the first one, which one is the second one? It doesn't matter as long as you do them correctly, right? You do the y's first and then the x's on the bottom, okay? It doesn't matter which one you do which one you do first. If you can switch your x2s and x1s and y2s and y1s around, you're going to get 1/3 no matter what. Yes? Good? Okay. Now, last one. Example 4. Find the slope of the line shown at the right. Okay, let's do some brainstorming. Let's figure out how we can find that slope.
Pick 2 points on the line.
Pick 2 points on the line. Okay, so am I gonna pick like this point right here?
No.
No, we're not crossing exactly. I want it to be like a point where he's intersecting like a cross exactly. So where's a good point?
Negative 2, 0.
Negative 2, 0. He's crossing there exactly, right? This guy right here? He's crossing there exactly. So at negative 2, 0, you said, right? That point right there crosses really nice. Where else does it cross really nice?
0, negative 3.
0, negative 3. This guy right here, right there, 0, negative 3. Okay? Now, I can do y2 minus y1, x2 minus x1, right? But since I have the graph, let's do this one a little bit easier. Okay? Slope is rise over run. Okay? I'm going from this dot to this one. This one comes first because I'm going left to right, right? Okay? So how much am I rising from this point to this point?
Negative 3.
Negative 3. I'm going down 3. 1, 2, 3, right? Going down 3. So I'm rising a negative 3. Does that make sense? I'm rising a negative 3. No? You're rising a negative, which means you're not rising, you're going down, right? You're rising a negative 3. So from here to here, you're rising negative 3, you're going down 3. Does that make sense? Now how much are you running across? 2. You're going over 2. Is it positive 2 or negative 2? Positive 2. 1, 2. So 3, negative 3 over 2 is your slope. Does that make sense? Now, looking at that number, let's say I didn't put it as a rise negative 3. Let's say I put it as a positive 3 because like Clayton, I'm like, that doesn't make sense to have a rise of negative 3. So I'm going to put it as a positive 3 over 2. How do you know that 3 over 2 is not correct? Hey, look at this line. Is he sloping upward or is he sloping downward?
Down.
Left to right is how you read the graph. He is sloping downward. If I have a little imaginary car on this line going left to right, my little car, doot, 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 doot. There's my car. He is going downhill, so I know that my slope has to be negative. This one is right, this one is not right. Does that make sense? Okay. You do the up and down value over top of the left and right value, and then it should be going downhill, so it's negative. Does that make sense? You are more than welcome to do y2 minus y1 over x2 minus x1. You should get the same answer, right? But since you have the graph, you can just look at it. Yes? Good? There you go. That's it. Perfect.
Okay.